Today we discuss one important topics related to abstract algebra. We know about that this group theory. Okay, this important group theory. Obviously, this was that means evaluated by some great mathematician. Here, that means they are solved some polynomial equations, and after that they find some pattern. Okay, then I think this group theory is evaluated. Okay, so now we start from definition of group. Okay, we'll not discuss more about group theory. Now we start from this definition. So we write it definition here. Okay, we write it in this way. Definition: a group is an order pair. A group is an ordered pair. Okay, G star, where G is a non-empty, where G is a non-empty set, and star is a binary operation on G. Star is a binary operation on G. Understood? Such that the following properties hold. Such that the following properties hold. Such that the following properties hold. Understood? First one we write it here, G1. For all ABC, belongs to G, here A star B star C equal to A star B star C. Okay, understood? This one are equal. Here G2, we write it in this way. There exists A belongs to Z. Okay, there exists E belongs to Z for all A belongs to Z. For all A belongs to Z, here S star E equal to E star A. Understood? Not a problem at all. So next, G3, we write it in this way. For all A belongs to Z, for all A belongs to G, there exists B belongs to G such that A star B equal to E equal to B star A. Understood? This one is the existence of inverse, this one is the existence of identity, and this one is the associative law. Okay, not a problem at all. Then we also see about that, and another one, obviously some closeness property, that means A star B is here, but we not discuss this one now. That means a group is what? Is an order pair, where G is a non-empty set, that means contains some element, and star is a binary operation. Binary operations, we know about this binary operation. Okay, then also discuss in this way. That means for all ABC belongs to G, A star B star C equal to A star B star C, and there exists E belongs to G such that for all A belongs to G, A star A equal to E star A, and for all A belongs to G, there exists B belongs to G such that A star B equal to E equal to B star A. Understood? Then we also write it in this way here. That means again we also see about that. this one is a mathematical system. Okay, here we satisfying the axiom 1 2 3, and obviously we see about that. That means here some closedness means some not is a binary operation. Okay, this one happened means then some closeness is then a star b belongs to z. Okay, if a b belongs to z, this one is happen. Okay, so we now write it in this way. A group is a mathematical system. A group G star. A group G star is a mathematical system. Is a mathematical system. Okay. Is a mathematical system satisfying G1 to satisfying G1 to G3. G1 to G3. Understood? Not a problem at all. So we now going to discuss one theorem related to that. So we erase that portion and going to discuss one theorem now. Okay. We write it here theorem. Understood? Let G star be a group. Let G star be a group. Then first one, there exists a unique element E. A unique element E belongs to G such that E star A equal to A star E equal to A for all A belongs to G. Second, for all A belongs to G, there exists a unique B. There exists a unique B belongs to G such that A star B equal to E equal to B star A. So we now prove of that. Okay. Here, just be a group, then there exists a unique element E belongs to G such that this one happen. And obviously for all A belongs to G, there exists a unique B belongs to G such that this one happen. Okay. So we write it in this way. By G2 there exists E belongs to G such that E star A equal to E and A star E equal to A. Here for all A belongs to G. Understood? Since G star is a mathematical system, since G star is a mathematical system, since G star is a mathematical system, then what happened? E is unique. Understood? E is unique. Okay. That means if we write it here, A star E1 equal to A, then obviously A star E1 equal to A star E, then also going, then write about that E equal to E star. Okay. In this way, we also do this one. Okay. I think this one have not a problem at all. So we also see about that. Okay. That means here we write some A star E equal to A star, that means if, then what happen, how this one be unique? Here A star E equal to A and A star E1 equal to A. Okay, then what happen is here, in this way we also write it now, this one. That means here this one, this E and E1. Okay, if we, that means continue E star E1, because E and E1 are belongs to G, E and E1 are belongs to G. So what happened? E star E1, if we continue E is identity, then this one is E1, and obviously E star E1 or E1 in this way. Then if we talk about E1 is identity, then this one is E, so this one are remaining same, E equal to E1. Okay, we write it in this way. This implies that E equal to E1. Then obviously we also that means going to this second part, for all A belongs to G, there exists a unique B belongs to G such that this one happen. Okay, so we erase that portion and going to discussion another portion. Okay, now so we erase this portion and going to discussion another portion now. By G3 there exist, by G3 there exist B belongs to G, B belongs to G. What happens such that A star B equal to E equal to B star A. Understood? Then what happened? Then we write it here. Suppose there exists C belongs to G. Suppose there exists C belongs to G such that A star C equal to E equal to C star A, then what happened? Then we show that B equal to C. Okay, we show that B equal to C. Okay, then how this one happened? I think this one is, that means too easy portion. How we deal about it? Here we write in this way: B equal to B star E. We know about that. And A equal to what? A equal to A star B. Okay, not a problem at all. If we write here A star C, then obviously not a problem at all. Then we also write it in this way: B star A star C, not a problem at all, equal to E star C equal to C. Okay, so B equal to C happen. We just use here associativity of this binary operation star. Okay, then what happened? So we write it in this way: thus B is unique. Thus B is unique. Okay, understood? So we write it in this way: the unique element E belongs to G. The unique element E belongs to G that satisfies G2. That satisfies G2, okay, is called the identity element. Is called the identity element. Okay, of the group G star. Of the group G star. Okay, next we talk about that. Here let A belongs to G. Let A belongs to G, then the unique element B belongs to G. The unique element B belongs to G, okay, that satisfies G3. That satisfies G3, okay, is called the inverse of A. Is called the inverse of A. Understood? I think not a problem at all. So again we also talk about, that means we know about group. Okay, this one is, that means some composition of function. Okay, that means not is a binary operation, or star is a binary operation. And then we see about associative law, then existence of identity, and then existence of inverse. And this identity element is unique in a group, and existence of inverse, the inverse element is unique. Okay, now we also proceed further. That means which group is called abelian group, or which group is called non-abelian group. We now erase that portion and discuss about that portion. Okay, so we now erase the board and further discussion about something. Okay, so we write it in this way: if a group G star, if a group G star has the property that A star B equal to B star A. Okay, for all A B belongs to G, then what happened? Then G star is called a commutative group. Is called a commutative or abelian group. Understood or not? I think all are understood that. Okay, a group G star is called non-commutative. A group G star is called non-commutative. Okay, if it is not commutative, if it is not commutative. Understood? I think not a problem at all. So which group is abelian? That means those groups satisfies this property. A star B equal to B star A where A B belongs to C. Then this group is called a commutative group or abelian group. And non-commutative and obviously not commutative or non-abelian. Okay, we talk about this one is non-abelian group. Too easily, but we have to think about that more. Okay, first we know this basic fundamental tool clearly. Okay, I think this one are all easy portions, but if you clearly understand this one, then you also further progress about that topics. Okay, then that means you also think about how develop these topics. Okay, now we give definitions related theorem. So we start one some examples related to that group. Okay, so now we erase that portion because example means also familiar with this portion. Okay, example shows about that means how we connect with this with some familiar topics. Okay, that means this one a theory, abstract theory, how we connect with this with some familiar, that means topics. This one shows by this example. So we construct this one z. We know about that z is for the set of integers. We also known about this one, the set of integers. Understood? Then what happened is here, then we talk about that z flash is a commutative group. Okay, how that means z with respect to class is a commutative group. How this one happen? We also known about that means this one is a binary operation. This plus is a binary operation. Okay, that means how this one is then satisfied. We also know about that a plus b plus c equal to a plus b plus c. Okay, and obviously that means a b belongs to z, then a plus b belongs to z. Understood? And a b belongs to z. I think this one obviously satisfied those. That means this one is binary property and some closeness property. Okay, and then this one is some associativity property for all a b c belongs to z. I think this one is happen. Okay, then we also further progress about that. We know about this one, 0 belongs to z and a plus 0 equal to 0 plus a equal to a. Okay, that means 0 is the identity with respect to this plus. And also further discussion about that in this way, a belongs to z and minus a belongs to z. then a plus minus 1 equal to 0 equal to minus 1 plus a. Okay, I think this one is not a problem at all. Not a problem at all, I think. Then what happen is here, then we also talk about in this way. Okay, that means minus a is the inverse of a. Okay, hence Z plus is a group. Hence Z plus is a group. Okay, here a plus b equal to b plus a for all a b belongs to Z. Then what happened? Commutativity property hold. Okay, then what happened? Then obviously this one is not a group, here abelian group. Oh, understood? So today we also discuss this one easily, and we also known about that this one are happened. Z plus is a commutative group, and in this way we also write about that. That means here Q plus, here R plus, here C plus, all are from a commutative group. Okay, all are commutative group or abelian group. Understood? We also discuss later this one, but today we discuss this one, this topics. I think this one is easy to all. We first discuss some definition of group, and then also we discuss some existence of identity element, existence of inverse element, and obviously uniqueness of inverse element, uniqueness of identity element. And then we also discuss commutative or abelian group, non-commutative or non-abelian group, and give one familiar example related to this group. Okay, we also talk about that means Lagrange also work on polynomial equations. Then that means he also need about that, and obviously Gauss do some portions about that. And then this one is, that means I think this one is developed. Okay, that means here we talk about another mathematician, Kelly, we also known about this one. And after in this renowned mathematicians also some renowned group discover. Okay, so in this way so many mathematicians are enriched these topics. Okay, so we also developed this one, but we just start today. Okay, so I think all understand this familiar topics. Today I stop here. If you get this type of video, please subscribe my channel. If you have any questions, comment, suggestions, write it in comment box. If you want to give like, please click on like options. Thank you.